Okay, let's say we have a pole stand 75 feet tall. An angle theta is formed when wires of various length of x feet are attached from the ground to the top of the pole. Find the rate of change of the angle when the wire is 236 feet is attacked. Okay, so I draw the pole. So the pole is right here, 75 feet tall. And then the angle formed by the wire and and the ground. So the wire X and the ground theta. So this is the angle theta. So we want to find the rate of change of the angle. So whenever we want to find the rate of change of the angle, it means we need angle theta equals something in order to take theta prime, the derivative of theta. Okay, so the first thing that for this problem that we need to do is we want to find what theta equal. Find what theta equal. Okay, so in order to do this, the only way that we can connect to this problem is using trigonometry. So let's take a look at what the given we have. So this is angle theta. The one that on the across the data is opposites. So this is my opposites is 75. And the one that is the highest, I mean the longest length would be the hypotenuse. So this is the hypotenuse. So anything with opposites and hypotenuse, what we use, we have so-called toe, right? So so-called toe, the one that using opposites and hypotenuse is sine. So the so we need the use the sine function. So sine theta is equal to opposites over hypotenuse, which is 75 over x. Okay, one more time. Sine theta is opposites over hypotenuse, so we have 75 over x. Now, but we only want the equation of theta. We don't want the equation of sine. So can I isolate theta? Yes, we can use an inverse, right? Because on the above, we know that y equals sine inverse of x mean x equals sine of y. So we just interchanging the input. So we have theta will be sine inverse of 75 over x. Okay, so to find the rate of change of the data, it means we take the derivative. So what is the derivative? So d theta over dx will be d sine inverse uh 75 over x. All right, so now uh, let's connect to the concept above. So sine inverse, derivative of sine inverse. So derivative of arc sine u is 1 over square root of 1 minus u squared times u prime. So what is my u here? My u here is 75 over x. So u is 75 over x. If I rewrite this as 75x to the power negative 1, then what is my u prime? My u prime will be negative 75, because I bring down the negative, x to the power negative 2, which is negative 75 over x squared. All right, so we have our u and we have our u prime. All we have to do is replace everything. For our formula, we have 1 over square root of 1 minus u squared times u prime, which is 1 over square root of 1 minus u squared. What is u squared? U is 75 over x, so minus 75 over x squared. Times u prime is negative 75 over x squared. Okay, so this is the rate of change of the angle with respect to x. But the problem is also want to find the rate of change of the angle when the wire is 236 feet. So it means what is when my x is 236? What is the rate of change? So all we have to do is putting 236 and evaluate it. So 1 over square root of 1 minus 75 over 236, the whole thing squared, times negative 5 over 236 squared. Okay, when you're putting the calculator, make sure you're putting carefully because this could be a common mistake for, or user error. So we will have 1 minus 75 over 236 squared take the square root of that, and we take 1 over the square root times negative 75 over 236 squared. And my answer will be negative 0.0014 feet per second. The problem doesn't say second of feet, so I will say feet per second. So it means the angle is actually, and the derivative is negative, so the distance will be decreasing. So I mean the angle will be decreased by negative 0.0014 feet per second.